Excellent. All right. Thank you, everyone, for joining our special interest group meeting on artificial intelligence and measurement in education. Today, we have the great pleasure of having a speaker, for Harold Duran, who's going to talk to us about some use of language models in educational standards. The usual we have, by way of introductions, our executive board consists of myself as a co-chair, as well as John Whitmer and our powerhouse secretary, Maggie. And we are all here. There's just a few items of business before we get to the speaker. First of all, our speaker is Harold and Reese. Sorry, I forgot to mention Reese Butterfuss from the Human Resources Organization. The first thing that we need to mention is that the NCMA schedule for the annual conference has been released and is now available. So I think that's still somewhat in flux, as in our SIGME session has been moved, but I think we've moved it to Friday. Is that correct, John?
That's right. It's right after the opening keynotes on Friday. I think it's 10 a.m. local time, if I'm not mistaken. But yeah, it may not be on the formal program yet, but mark your calendars.
Yeah, so we hope to see everyone there, and it should be a fantastic session. We've got a good lineup of speakers. The second thing is that we're planning an in-person get-together on Saturday, and stay tuned for details. We would like people to sign up for that, but we're probably going to go out for drinks, and we have a certain allotted budget for that from NCME to facilitate that meeting. So I hope that everyone can join that, and we're going to have a lot of fun talking to each other. We figured that something more informal is probably better than a formal get-together where we all have a little bit of fun. Okay, so with those formalities out of the way, let's get to the main meat of the meeting, which is our speaker. So our research presentation is from Harold Duran and Reese Butterfuss from the Human Resource Organization, and their talk is on an application of text embeddings to support the alignment of educational content standards. And I'm going to stop sharing. And Harold, it's on to you.
All right, let me take a moment and find my slide deck. I'm going to share this one moment, please. Chris, if you could let me know when it's visible to you.
Excellent. It is visible now.
Okay, wonderful. So first of all, let me just start with some gratitude. We think this is an important group. I'm really grateful that the organizers have allowed for us to spend some time with you all today. And we would also like to extend an invitation, please, to interrupt, ask questions as we go along, or feel free to hold your questions until the very end. Just one caveat, I can't necessarily see if somebody has a question in chat while I'm presenting, and I'm not sure Reese can either. So please know that if you're asking a question in chat, I'm not ignoring you. More than happy to answer any questions about what we're thinking, about what we're doing, and the work that we're involved in. The second caveat is this continues to be a work in progress. Reese and I continue to learn. We continue to find things that we wish we would have done differently, or wish we would have done more of. We're sort of kids in a candy store when it comes to this work, as many people are. We're excited about what we have to share today. So why don't I jump right into it? All right, so just by way of introduction, my name is Harold Duran. I'm joined by my colleague, Reese Butterfuss. We're with an organization called the Human Resources Research Organization, although we don't go by that, we go by HUMRO. Today, we're going to talk about the major findings. We're going to hit the wave tops, so to speak, of the work that we've recently been doing. There's a lot of other stuff that we've learned. And the white paper that's on the right-hand side there that has been shared has more details, has more information, has other findings, has some math, has better descriptions, and so on. So today, we're just going to try and talk at a high level and be descriptive. We hope not to be technical much at all. We won't show any formulas or math or equations. We're going to try and be descriptive so that those of you who are interested in the formalities, please refer to the white paper. although we're happy to answer any questions about any formalities that you might have as we go along. Okay, some objectives for our talk today. Excuse me. Number one, we're going to describe the educational measurement problem and its challenges with large text data. This is an educational first problem. And so we view, I think in the world of AI right now, a lot of folks have a solution and they're looking for a problem. We've been in the situation where we've been doing this work for a long time, and we have a problem that needs a better solution. And so the language model and the way that we're using and talking about it today has been a really great aid to the work that we're doing. It's a nice sledgehammer, but we feel like it works quite well in this particular problem, but we're starting with the educational measurement problem. Everything that we're talking about begins there. We're going to propose an approach that uses NLP as a supporting mechanism. So we're going to introduce some terms. We talk about NLP assisted and NLP driven. They're terms that we think we created, but no big deal. But we think we're just organizing a framework. In fact, part of what we're doing is simple and intuitive. There's nothing here that is so rocket science amazing that we think it's all that impressive. We think we're making just pretty straightforward, simple use of how these language models can help humans. We'll demonstrate the method with some real data, and then we'll think a little bit about how it might be used in other settings. Just got one thing on my slide. Okay, so let me jump right into the why would we even want to do this to begin with? Well, number one, these content mapping activities that we'll introduce in just a moment take a long time, or they can take a long time, depending on how they're structured. Hummer has been doing these content mapping workshops for a long time. Sometimes they take many weekends. Sometimes they can be done quickly. So there's a lot of variability in terms of how they can be done. But one of the things that we're learning with our method here is we think we could reduce the amount of time panelists spend in these workshops. We think that's really fundamentally important. And if they're spending less time in these workshops, we think that makes them more efficient, and then it will reduce the costs. States or districts spend quite a bit of money on these workshops. And if we can make the human effort smaller, we can make the costs smaller. And then third, we think we can reduce the cognitive overload, and the likelihood of errors will also be smaller. So often we find that people become overwhelmed with the number of text pairs that they have to analyze and look at. And we think if we can make a big problem smaller, we think we can solve these three problems. So let me do just a quick generic introduction, and then I'll turn it over to Reese in terms of what we're talking about. We're going to relate this back to education in just a moment. But suppose I have two sets of text. Set one is in column text A. Set two is in column text B. And suppose I ask a group of panelists, take this statement here, teach kids how to swim. And now look in text B and look over all of those statements in text B and find the statement in text B that seems to be most similar to teach kids how to swim. Well, a human would look at this first one, then they look at the second one, they say it's not there. Design pants and shirts, no. Serve as a pool lifeguard, maybe. Work as a swim teacher, that seems likely, and so on. Then they move to the next one in text A, drives trucks, loads gear, rides bikes, and they do the same thing. Now they pour through all of the statements in text B, and they find the one that seems to be most similar. Of course, in this very small table, it's completely doable by a human. There is nothing overwhelming with this task here. But suppose text A has 100 statements. Suppose text B also has 100 statements. Then the number of pairwise comparisons is 100 squared. Suppose it becomes even larger. You have 100 statements for text A, 100 statements for text B in grade 3, and then also in grade 4, and then also in grade 5, and so on for math, ELA, science, and social studies. You can very quickly imagine this task becoming large and overwhelming. So now we'll relate this to the educational measurement problem, and Reese, I'll pass it over to you.
Yeah, hi there, this is Reese Butterfuss. Promise that's my real name. Some people wonder sometimes. What Harold just showed is is a general example of what it means to match text. And I also want to add that it's not as if you can always find the match and stop. Sometimes there's multiple matches that would require you to actually indeed go through every possible pair to ensure that you found all the matches. But what does content mapping look like in practice? It entails creating a crosswalk that maps or aligns different standards or items together to establish the extent to which they're comparable. Are they covering the same things? So some examples from practice are aligning the next generation science standards to the NAEP science framework, or aligning state standards to NAEP standards. Humro's done some of that kind of work. Aligning off-the-shelf tests like ACT or SAT to the Common Core state standards, aligning dynamic learning maps to national standards, and then aligning English language development standards to general standards. And alignment involves content mapping between two sets of items. And in this presentation, we're focusing on two different sets of standards. And it's an essential component of the validity argument for an assessment. And it's required by the standards for educational and psychological testing and for the U.S. Department of Education peer review of assessments. Some common types of alignment, at least that Humro does, involve aligning two sets of standards, like I said, or aligning individual assessment items to state standards, for example. And how the task typically unfolds, at least at Humro, and at least as far as I've been involved with alignment, generally involves assembling panels of experts, often one panel per grade level per domain, so like ELA or science or math. And you bring these experts together, they're usually teachers, and their task, in the event they're aligning two different sets of standards, for example, if they're aligning state standard with NAEP standards, their task is to ask for each state standard, what is the best aligned NAEP standard? And they use their judgment, their expert judgment, to determine similarity. And then oftentimes there's a discussion to reach consensus in the event that the panelists don't agree on what is the best aligned standard. And oftentimes these workshops, like Harold said, take place on the weekends or sometimes in the evenings after they've worked a full day or a full week. So they come into the task pre-fatigued. And then we're asking them to do this task that is by nature very fatiguing. So some common problems that arise come from just the large number of potential pairs, just the burden that we place on SMEs to deal with all this text we throw at them. It entails a large time commitment, usually several days. And then with that comes fatigue effects. And then, as a consequence, error. We've noticed that during these alignment workshops, the more fatigued these teachers become, the more prone to being overly agreeable they become, or they're just, even if they don't agree, they just say, yeah, whatever, let's just move on, because they want to get the task done. So for example here, let's say the task is to align 45 state standards with 38 NAEP standards. That's 1,710 potential pairs that the SMEs have to contend with. So, it seems obvious that the task could be improved. And some other researchers have begun looking at how to use AI and NLP to improve how alignment happens. And we came across only a couple studies that use large language models, transformer models, like the cutting edge NLP research out there, and applied it to alignment. But these two studies have used large language models to essentially automate the task. They're much more focused on automating the task. There's a lack of work in developing an NLP or AI assisted process that keeps humans centered as the key decision makers rather than trying to have the NLP model make decisions. So in our approach, we wanted to use NLP to lighten the workload rather than to automate the workload. And we thought one way we could do that is by leveraging semantic similarity, because that's the basis of SME's decisions, of the panelists' decisions for what is aligned. They look at sets of standards and they choose the ones that are the most semantically similar, that mean the same things, even though they might have different words. And then the goal ultimately is to reduce the search space, or in this case, to reduce the number of likely pairs that the SMEs have to consider. So this figure on the right shows what it could look like to identify the most similar pairs between two sets of standards and to show the most likely pairs first.
Okay. So we've introduced the problem, and I can see the comments here, which are all very good comments. I mean, for those of you that are experienced with this, this is hard. It takes a long time. People get fatigued. And I see, some comments on, especially as people get closer to the end of the workshop, sometimes people just become more agreeable. They say, okay, whatever you said, I'm just going to go ahead and agree to that. And they just start to move on. So then we started to ask ourselves, well, what can we do? And how can we make use of the embeddings? So we started with a question, just a question out of curiosity. Can NLP-based approaches be used to form a reduced search space? And so we thought about a number of different technologies that are commonly used with language models right now. So there's one shot where you can take a text statement and ask it to classify with some probability. There's few shot where maybe we could train the model with some small examples and then do some text classification. There's the cosine similarity after you get the text embeddings. And so we sort of thought about the different ways to use it. We settled on one. We think this is a pretty good one. There's probably other ways to do this, and others we're exploring, as we shared a moment ago. But we'll share some data that seems to suggest this seems to be the right tool to do this job. So we started with a question of curiosity. It's a big problem. Can we make a big problem smaller? But then we had to ask, instead of just running some numbers and doing some analyses, can we actually build a methodological framework? So in other words, instead of just saying, go get text embeddings, can we actually build this into a sort of logical process that works for this particular problem? And what would that methodological framework be? But then we had to evaluate this, and we'd ask, well, if we do it this way, what's the probability that the true match, and by true match, what I mean here is that statement A matches statement B in reality, that there's a true match between them. What's the probability that that true match would live within the smaller search space? In other words, if we're asking panelists, don't look at every standard, only look at these top 5, then there has to be some data that suggests with a very high probability, the true match actually lives within those top 5. So we evaluated that, and we'll share some real data results. And then we started to ask, well, if we can make this work, and there's data to suggest that it looks promising, what are the applications? So a couple of terms that we use, we're using the term NLP assisted and not NLP driven. This is just a term that Reese and I started talking about. And what we want is for subject matter experts, the SMEs, to still be at the center of the expert judgment decision-making process. We don't want the language model itself to form the classifications, like the second bullet says. We just chose not to do text classification because we think that could lead to some confirmation bias and maybe lessen the role of SMEs. Of course, there are ways where we could say, well, just show me, still use text classification, but show me things that have a probability bigger than 0.7 or some number. So there's still ways you could do it. But that was the reason that we're doing it the way we're doing it now. We still want SMEs to be at the center of the process. We don't want the language model itself to drive the classification. Okay, so now what is the traditional process? So the traditional process has some statement, A1. That's a language statement, a standard. And then SMEs ask the question, and they pour through a set of standards. Does A1 match B1? Statement B1. Does A1 match B2? And they systematically go through these, and they generally are unordered, right? Not always. Some people might find a way to order them, but generally they're not ordered in any way that's coherent. And then the panelists might find that it matches some standard later on in the set. All right, so they go through some number of standards until they find a match or multiple matches or no match at all. So can we improve on that? So what we've developed is a method that sorts those standards by subsetting them or ordering them in a way where the most likely match to this particular standard exists in the top P. That's the term that we use. We think P about equal to 5, as we'll show, seems to be about the right number. But the formal goal is to see if we can order the standards in some logical way so that panelists look at the thing in B1, which has the highest likelihood of being the right match, then 2, a little bit less than B1, then 3, then 4, and so on, until they get to about here. The analogy is similar, not exactly the same, but similar to the bookmarking method of standard setting, where people look at the test items ordered by the RP value. So this is not an RP value, but they're ordered in a way of some increasing or decreasing order of coherence or relationship to the standard they're intending to look at.
Harold, this is John jumping in to ask a question. That's a clarification question from John Wilsey. He asks, it looks like you're suggesting that recall is more important than precision if we wanted to get more technical about it in returning potential values. Would you agree to that? Because it sounds like you're talking about a sort order and not capturing the universe of possible, and that, yeah, I'll stop explaining the question.
Let me answer the question in the way that I'm understanding it. And if I don't answer the question the right way, please follow up with me. I think we care about both. So here, we think that the things that would be most related to this particular standard here would fall within this subset. There might be one, there might be multiple. They would be clustered in some logical way, so that by the time they get down here in the subset, the things that are down here more or less have no relationship to this standard here. So we really do care about precision, that we want the right match to be found. And we think the best way to do that is by ordering them in some logical way. I hope I answered the question that was being asked. If I didn't, please let me know.
John, can you jump? Do you want to jump in or unmute yourself?
Yeah, sure. Yeah, sure. No, I think you answered it. Just in prioritizing recall over precision, I guess the idea is to make sure that the true matches are all represented so that your SMEs can choose from among them.
Yeah.
Whereas I guess if you were focusing strictly on precision, then you'd run the risk of missing some potential matches to make sure that the return set has fewer spurious matches.
I got you. Good question, John.
Yeah.
One of the things that I'm with you actually, and I think the way that our method works, we believe, is no risk of missing precision, because we wouldn't ask the panelists to stop here. In fact, if they felt that they needed to keep going, they could. They could just keep looking at the standards if they wanted to continue doing that. But if they felt pretty confident, yep, I found the match in the 3rd position, and I feel really confident that that's the right match, they could stop there. But we feel like there's less risk in our approach, because we're not saying stop. We're saying, hey, if you want to keep going, keep going. Okay, so I've sort of outlined the sketch. Let me talk about how this would unfold in a real world setting. Supposing we have 2 sets of standards, we would say compute the text embeddings for all statements using some language model. We'll show some of the language models that we used, and just as a quick preview, we didn't find that the embeddings or the semantic similarity between them mattered much between language models out of the box. We didn't fine tune any language models, even though we have labeled data, we used them right out of the box. And just computed some embeddings in something of a vanilla way. Then after you have the embeddings, compute the cosine similarity between all pairs, sort each statement with its corresponding pair in order by the cosine similarity. Then you ask the SMEs, let's go through these until you find the match. Let me show you an example of what that might look like. So here's one state standard. It's a real state standard. Here's a real NAIP standard. So I'll read this out loud. Describe how changes in vibration affects the pitch and volume of sound. Well, the NAEP standard, vibrating objects produce sound. The pitch of the sound can be varied by changing the rate of vibration. The cosine similarity between those two text embeddings under one of the language models is 0.73. The next statement, in descending order, objects and substances have properties. Weight, mass, and volume are properties, blah, blah, blah. The cosine similarity there is 0.41. So you can see we've taken this one text statement, compared it to all the other NAEP statements. There's more. We just happen to cut off some here. We're just showing the top 5. And you can see they're sorted in descending order according to the cosine similarity. That's all we've done. But now we need to ask the question. And by the way, in this particular example, the true match, or the true match as determined by human experts who actually did some work on this in advance of our study, labeled these two as being the true match. So we have real labeled data. So now we can ask the question, if we were to do this, how often would the true match be within the top P ordered cases? And I'll hand that over to Reese. Oh, we'll describe our data and how we got there first. Reese, go ahead.
Sure. So we wanted to apply this method to some labeled data we had to evaluate its accuracy. So we used data from a previous alignment study at HUMRO. The National Assessment Governing Board in 2020 tasked us with comparing the non-NGSS state standards to the NAEP science framework. During the study, it involved 3 grade levels. There was a different panel of experts, of teachers for each grade level, and their task was to align each state standard with a NAEP standard. There were 33 states represented in the data, and the number of NAEP standards, of course, varies by grade, and the number of state standards varied by grade. And then we include just the total number of potential pairs in the right column there, just to illustrate, like, that's the number of pairs that our method actually evaluated. And more details are available about this study. There's actually a link to it in the white paper, but it's on the National Assessment Governing Board website. So this is the basis of our true matches. So we actually had human evaluation to determine what the true matches are. And then we wanted to democratize the method to allow people to use it even if they're not Python programmers. So we developed a web app that we're calling Sprint, stands for Semantic Processing, with robust embeddings using innovative NLP and text analysis. And it also works because it's super fast. And how it works is you put your 2 sets of standards in adjacent columns in a CSV, and you load it in, and then you choose which language model you want. Right now, it's just furnished with some popular freely available ones from Hugging Face. You can normalize them to make sure they're all a consistent range and so on. And then you submit it, and then the results are, for every possible pair of standards, you get the cosine similarity. And then you can download this as a CSV and do any subsequent work with it you want. Yes.
So just as sorry, Reese.
Oh, no, there's a little question that popped up in the chat.
Yeah, so this particular analysis, the 25,410 pairwise comparisons in the software was done in about 10 seconds, right? So imagine how long would it take a human or groups of humans to make 25,410 pairwise comparisons of text? It's a lot.
So in terms of results, we wanted an accuracy metric that would directly inform how we use the method. So for now, our accuracy reflects how often the true match exists within the top P ordered cases, and P can vary, starting at 1 to whatever you want. Recall that we have true matches according to human judgment. And then we, in the subsequent slides, break down for each language model, what does the accuracy tend to look like. So here, this is for the grade 4 data. We have P on the x-axis and then accuracy or proportion on the y-axis. And this shows that within the top 5 pairs, there's a true match about 95% of the time. The one there on the x-axis shows that the single highest cosine similarity pair is a true match, according to human judgment, about 55% of the time. So I think, and I have guidelines there. We can move on to grade 8.
Although it's also interesting to see, not only do we have like a 95% chance that the true match is within the top 5 of all, 30, 40, 70 standards, but the language models don't have much variability in their behavior. They seem to behave quite similarly.
For grade 8, it tells pretty much the same story. We're at about 95% accuracy within the top 5 pairs. So overall, I mean, I was surprised by how well it worked at first. And even less variability, I would say, here in terms of how the language models are performing. And then we have grade 12, and the accuracy is actually higher. So we're at 95% within 4 pairs. And I thought it was interesting that the accuracy tends to improve slightly as grade level increases, but some post hoc analysis we've done has shown that the cosine similarity values tend to be a little higher for the higher grades. So I have a suspicion that what's happening is, there's more specific language used to communicate the more advanced standards for the higher grades, and then the language models are sensitive to that more specific language. Whereas in grade 4, the language is more general because the standards are more general. And I think it's especially important to highlight what you would expect if the standards were randomly sorted. So if you just randomly sorted all the standards, what is the probability that a true match would appear among the top 5? And it's less than 15% across grade levels, whereas our observed results are, about 90% or higher within the top 5.
So essentially, there's, this is about the only technical thing we'll get to. The math is derived in the white paper, but this is effectively the null distribution. What's the probability that the true match would live within the top 5? It's much, much lower than this. I mean, so the fact that we're getting 95% accuracy relative to a null distribution that would expect about 10 to 15% is a pretty gigantic, difference, pragmatically speaking, not even speaking statistically. It's just a big difference.
And the results I just showed aggregated the data across 33 states. I wanted to see how well the results tended to generalize across states. So I used data from all states to create confidence intervals. And these show that in general, there's not that much variability across states. So the results tended to generalize. Like, for example, in grade 4, at like the worst case, we're at about 90% accuracy within the top 5 pairs. And that's for the worst 5%.
Yeah,
and then I want to also just clarify that the confidence intervals don't extend all the way to the right, because that far to the right, there's no variability because it's only a single case going out that far.
And just to maybe foot stomp something, this is a really encouraging result, because not only do we see that the language models behave similarly, we see that the method, when disaggregated across all of the states that were used in this analysis, it seems to behave the same way across all of those states. In other words, trying to make claims that it didn't just work in this one particular scenario, it seems to work pretty broadly across all of these states, across all the grade levels, across all the language models. In fact, Reese, that's kind of the point here.
Yeah, so I think the major finding that I hope people can take away is that a true match exists within the top 5 ordered cases around 95% of the time across states, across grade levels, and across language models. So I guess the practical upshot is that 95% of the time, the panelists would only need to see the top 5 pairs. And then we were thinking about this, and we realized that this method could also help a few of the problematic conditions that can arise during alignment. So oftentimes during alignment, the standards are not just randomly sorted. They're grouped by domain or subdomain as an organizational framework to help with alignment. And a lot of times panelists will use prior knowledge when they, they read a standard and they say, ah, this sounds like it would be most closely related to this particular domain. So they go look for standards in that domain and they find one. But there could be another relevant standard in a different domain, and they're not looking at that domain. So this would actually pull those standards together and put them up top because they're likely highly similar. It would also help the panelists quickly determine that a standard has no match. So sometimes there's a unique standard. There's no corresponding standard in the second set. And if you're, reading and you're at the 10th rank ordered pair and it's not similar, it's likely the case that there's simply no match for that standard.
So, we've had an opportunity to present to you all, and we have so much more. We had so many slides that Reese and I ended up cutting out because we thought we would push beyond the hour. But we really would like to engage in just some conversation, but with a couple caveats. We really continue to learn here. We're still thinking about this. And I think we're also making the claim that nothing here is surprisingly novel. It's a pretty straightforward use of text embeddings. And all we're trying to do is take these language models and make them work for us so that we can do a little bit better at the work that we're doing. We've had some friends help us out with some thinking, and we want to acknowledge those of you that have helped us out. So Don Peasley at the department, Sue Lottridge, our internal colleagues, Dan Putka, Insu, Pak, Haishang, Emily Dickinson, Art Thacker. So we've really had some great partners help us think through some thorny issues. We want to say thank you to you all. But Chris, we're done with our formal part of the presentation. We'd love to just talk and just chat and hear people's reactions, critiques. Hopefully there's no critiques. They're nice critiques. But no, we'd love just to listen to you all and see if we could talk about the work we're doing.
Yeah, I would like to open up to questions, but I have a question. First of all, is there any studies into the agreement levels between, say, the SMEs on what the correct standard would be or the correct matching?
I'm not familiar with any studies. It's a good question. I'm a little just uncertain about the answer to that. Maybe others on this call who've worked on alignment studies might know the answer better than I.
Okay. There was one question as to, if I might, somebody raised the possibility of this data set that you've got, where you've got the matching standards. Would that be able to be made available for people to test? For example, maybe test the effects of, say, fine tuning of these semantic searches.
Reese, we do know that the data were at one point publicly available and on the governing board's website. And Reese was going to look and see if they still were available. Reese, were you able to find that?
I found the report. I didn't find the data, so I can follow up with the HMRO people who were in charge of this study to confirm whether we can make these available.
So we know that at one point they were, but we can't right at this moment point to where those exact data do live.
Okay, let me open it up to does anyone want to go off mute and ask a question?
Yeah, this is Sue. I'll ask a question about this. What are your next steps, Harold? Because I can see, when you go live with this, then what you're doing is, changing the information available to people. And how would you kind of examine how well this is working in practice? Do you do a pilot study with known data to see if it's impacting actual panelists, or how are you thinking about that? Because the results look just fantastic, honestly.
So probably a couple of things. I'll say something, and then Reese has been thinking a lot about the next step. So first of all, hi, Sue. And Sue, your contributions to this work have been great, and we're all grateful for the thinking that you've done. So where do we go next? One, we still need to think about this a little bit more. This is not quite ready for prime time just yet. We do have some partners that are about to explore this with HMRO in some pilot studies to see how well it works out. We also realize that the real world is a little bit more challenging sometimes than some data we have for the study. English language development standards, for example, are sometimes really idiosyncratic and unique, and maybe a little bit more challenging to match to, say, general population standards or other sets of standards. So we do need some more time to roll up our sleeves and struggle with some of the complexities of the real world and see how well it will actually work. So we want to try this with a few other data sets before we go much, much further for prime time. But also, we don't think there's too much of a risk in deploying this alongside a real content mapping workshop just yet. It doesn't do a whole lot of harm to have an organizing framework because humans are still at the center of the decision-making process. So we're a little comfortable with that. But Reese, you've been thinking a whole lot about some of the other things that we need to do. So I'll turn it over to you.
Yeah, I would say what's on my mind now are just kind of natural extensions of the method. So this was developed on standards to standards alignment, but Hummer also does a lot of items to standards alignment. And the challenge there is that there's often a lot less semantic overlap between assessment items and the standards they correspond to. Another thing I'm interested in is, is there a linguistic signature of items that are hard to align? So if we were to actually dig into the embeddings from these standards, would we find that there's something systematically different about the standards that were hard to align versus the ones that were easy to align? I'm also interested in testing, for the cases where there were multiple standards, how accurate is the method for capturing both standards that are aligned, for example, in the top 5? So I think there's just a lot of natural extensions that will kind of naturally emerge from this method.
This is John. I have two questions. One of them, it was raised, I think, by Sarah Bispel in the chat, was about accuracy, right? Because our ground truth here is how much humans agree about the agreement, right? There's no objective truth, as these are complex constructs that don't directly. It's not like we're measuring a physical object, right? So, have you thought at all about like reframing accuracy or inaccuracy as potentially identifying human errors or errors in human understanding? And how do you go about that? And I see Sarah, maybe Sarah wants to jump in because she said that first. Hi, Sarah.
No, thanks, John. That was exactly what we're getting at. And again, we're working on this problem also, so we're really interested, and thanks for this great presentation. So how you were going to start to answer that, I think, Harold? I was just curious what you're going to say.
So I was going to share a couple of things. One, thanks for the work that you all have done. We talk a little bit about the work, and we're familiar with the efforts that you're making. And you're exactly right. Yes, we talked a lot about this exact issue, that we're accepting the true match as being the match assigned by humans. For purposes of this study, we decided to live with it, right? Because we just wanted to move forward and get something out and start thinking about this. But in full recognition, with your very, very valid point that we're accepting that true match as being the human assigned match, when in fact, the humans could be wrong altogether. So a couple of thoughts. One of the things about the method that we've put forward, those labeled data play no role in how our method unfolds, right? So we could go into some scenario where there are no labeled data at all. We just sort them by their cosine similarity, and the SMEs end up making some judgment and final assignment of which things match. So in some respects, we're a little safe there because we're not doing anything that uses labeled data to train a model and get some probability of a match based on things that we fed into the model. That's one. I will give just an honest answer. I don't know how to deal with that, right? Like, we're actively thinking that through. Like, we've chewed on this and struggled with it. We thought, well, maybe the language model is just right. Maybe it's just better and the human's just wrong.
Yeah.
And especially as these language models get so sophisticated and so good with how much data are there. Sarah, please go ahead. You may have thoughts that please.
I was just going to say that we get this question because we have this alignment tool and again, this accuracy concept. So to your point, what we found is pointing at evidence. what is the evidence, either when we're matching items to standards, we really bring that out, allow that, so you can see that conceptual linkage, allow subject matter experts, if they're going to look at something, they can look at that. We also provide a rationale for each one of the tags. And so we find that when you're looking them over, we can kind of see and make sure those fine tunings that we're talking about, we can fine tune things when we see that maybe that rationale isn't working quite right. But we have just real quickly, one other finding we had was actually found with working with customers over time, that actually people have found that when they looked at we have catalog as our tool, but when we look at that assignment versus human assignment, they've changed their human actually tags back over to what was really being pointed out with respect to the evidence, either in the item or the text, to the objective or standard. So just a thought of maybe looking into that.
It's a great thought. Sarah, we'd love to find time to follow up with you if there's some availability and learn from you a little bit more. We're familiar with the work you're doing. I think your answer is a good one. And this is one of those like tough issues that John, we've sort of struggled with this and talked about this ad nauseum.
It becomes kind of weird in my experience. I'm sorry. It's like the human when we say AI in the human loop, then in this case, like AI could be supervising humans, which to me feels a little creepy, right? It's like, wait, maybe the AI is finding a problem in what we've done rather than saying, oh, the AI is wrong. That must be the target in the enemy. It's like, wait a minute, I think we've seen the enemy and maybe, right, the enemy is us in the training data that we could use that, but a little bit as an indicator or kind of canary in the coal mine to reframe that rather than just kind of an absolute error. When we're talking about something that extrapolates patterns found in the human kind of experience. We've seen that with automated scoring work that Maggie and I have done. We're like, whoop, that might be something in the item.
For the methodologists on the call, I'm starting to imagine a nice experimental design where you might randomly sort some standards, show those to a group of humans and ask them to find the match. And then do something like this, either through text classification, where you sort them by the probability of a match or by their cosine similarity, and then order them and say, now go and find the match. And I wonder how often they would change their answer from, oh, now that I see these things here that are the top 2 sorted cases, I believe these things are more likely to be the correct answer. That's about my 10-second thought on that. But there certainly is room to grow in that question.
I think
I have a question for you.
Oh, sorry, I think I'm cutting someone off.
No. Yeah, this is the first time I've spoken. I'm Dr. David Rogers, and I'm at American Military University and psychometrician for 999 Society. So I'm struck by the thought that we have multiple humans and one computer model doing this. Have we considered building many large language models and see where they agree? I think we could get better than 95% on the top 5 when we combine more than one learning model. Is that been considered?
No, I think we did that. So we actually used 5 different language models, and we found that the different language models converged to have the same probability of the true match. And I'm going to continue to use the term true match, Sarah and John, knowing that it comes from the humans. And so humor me for just a moment, but we did find that the language models continued to behave in very similar ways. We also did experiment with other bigger models, like some of the T5 variants that a lot of you are familiar with in the Hugging Face ecosystem, something called Vicuña. We actually found that those bigger, more expensive models were just costing us more money, and we're not adding any value to what we were getting with some of them smaller models in this particular problem. That may not be true with generative types of problems, where we might expect the language models to do a little bit better depending on the billions of parameters that these things have in them. But we did explore a number of different models, Dr. Rogers, and we do think that they, at least in our experiments so far, have behaved comparably.
That's awesome. Thanks.
Yeah, I will say that due to the popularity of RAG, there is a renewed interest in embeddings. In fact, a whole swathe of embeddings have been, created for retrieval or information retrieval, and these these ones that you're using are by no means the state of the art in terms of what people are using these days. There's current leaderboards that contain swathes of, you know, great models that you could try.
Yeah, you know, we acknowledge that. In fact, you know, we put in the white paper, you know, the reason we chose these ones because they happen to be at the top of the leaderboard at the time we started thinking about this. And these things are evolving so quickly, right? Like, you know, it's almost hard to catch up, but full acknowledgement, Chris, of what you're saying, that there are some better models, and text embeddings tend to get, you know, this world is evolving. However, you know, one of the things that that, you know, I would say is, how much better can we get than 95% chance that these models themselves are showing us we're the true match, again, the true match living in the top 5. So even with these things and their, you know, their ancient sort of existence, ancient being like 8 months ago, they're giving us pretty good results, right?
Yeah, absolutely. But I still think fine tuning might even improve that. So yeah.
I want to connect that back to something that Sue mentioned. It makes me wonder, suppose there were a concerted effort to build some language model that was trained on labeled data with standards that were a collection of matches collected across many states, across many content areas, and so on. Certainly would be an interesting thing if we had something that was education specific for this type of a problem.
If someone wanted to draft up a white paper, or this group wanted to do that, I am sure there are quite a few philanthropies that would be interested in doing that, or perhaps someone, I think that seems like a really big, there's a lot of work right now or interest in open source, freely available benchmark data sets and approaches, especially given that standards, they aren't student data, right? They're not private, right? For the most part, right? They, you know, they're intended to be openly available. It seems like that overcomes a number of those challenges, especially if people here have already developed them and done some of that. I'd be happy to follow up with you about that if anyone wanted to.
I also think one of the great innovations here is actually the user-friendly API that, you know, these special experts can just access fairly easily. You know, so yeah, there are language models, but getting people to use them is also, you know, an innovation in of itself.
Yeah, I don't know if what you mean by that is referring to the software we developed or the other APIs that exist from, you know, just calling the language models.
Yeah.
But part of our effort, Chris, was intentionally to build a really accessible platform.
Yeah.
So it's, you know, it's a Python backend with something called Flask on the front end, which is a pretty straightforward, you know, application framework for building Python-based applications. You know, we didn't want to be focused on writing Python code. We wanted to be focused on the substantive problem, and building out the software allowed for us to get to some answers pretty quickly.
Yeah.
And this is John, what's your intent there so far? You've got kind of like a MVP, but the deployment, you're still thinking through the way you would deploy this into classrooms? I assume this is not something you're open source licensing and making freely available. It's a product through Humro you would deploy as a service or rent out. Could you say a little more about the productization?
Yeah, happy to. Yeah, we're not a product company, and so we don't intend to like build software that we would allow for others to, you know, purchase or, you know, and so on. This would be part of a service that if we were to go to a state and they said we want to do this, this would be a way that we would, you know, supplement the work that humans would do. It is absolutely an MVP right now. You can see with the screenshots that the CSS that's there needs a lot of additional styling and so on. And so my CSS is all like borrowing great open source bootstrap that got me this far, but some real designers could make it much better. But we wouldn't, we don't have plans to deploy this for larger audiences. It's for internal Humro use. But we've tried to make the idea and the math and the things that we're doing so transparent that anybody who wanted to do this, everything that we're doing is made transparent in the paper. We think so.
That was the intent anyway. Yeah,
that's our goal. I mean,
yeah,
we're trying to contribute to science and society here, and that's our mission. So that's our goal.
And CSS styled Flask apps compared to human workshops of people debating paper seems like a pretty big step function change forward. I just want to say.
Yeah.
Now, I've just brought up the screen so that there are a few just calls for participation and some conferences that people might be interested in. So what do we have? First of all, there's the building educational application. So that's in June, but I bring it up now because the deadline for submission is March 10th. BEA is a wonderful workshop where a lot of people from this group actively participate in. So this is the sort of application that or conference that Harold's application might fit in very well in. There's also the ATP EdTech conference in March 3rd to 6th. Now that's in Anaheim, but I believe that there's also a online virtual participation if you're interested in that. So the EdTech conference is also run by a lot of people within this group. There's a webinar on AI-based assessment. So this is one of our members asked us to make this make everyone aware of this. We had a mail out about this as well. So please participate. Secondly, there's a teaching and learning with AI. That's in Orlando, July 22nd to 24th. There's an AI and Education Summit. That is tomorrow. But again, there's also virtual attendance if you're interested in that. And all the slides are going to be available by the end of the day on the AMI website. So second, there's also AI for Educators Conference on the 15th of July coming up. And lastly, there's a special journal issue that you might be interested in. And the deadline for submission is March 31st. And one very last thing, the form for happy hour, Maggie already shared it in the chat, but this is just something you can, click on and join if you're interested in meeting at NCME on the Saturday to discuss AI in measurement and education. Thank you very much, Harold and Reese. That was a wonderful presentation. And we're going to bring this meeting to a close.
Could I just say one more thing to make a pitch for the happy hour? It is a real happy hour. NCME is sponsoring it. We're thinking of a brewery. It's after a day with a lot of AI sessions at NCME. So seems like a good thing to do, and we're keeping it informal. So we don't have that. We're finalizing that right now to get some of the details, make sure it doesn't break the bank and those kind of things. But did want to just mention that for the details for the happy hour, because it's kind of good to know where and some of the details. Thanks, everyone.
Thank you.